Good afternoon, everyone. This is my presentation for homework number 3, problems 6A and 6B. So let's prove using mathematical induction for any integer n greater than or equal to 1. 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus n times n plus 1 is going to equal n times n plus 1 times n plus 2 over 3. So let's first do our basis and establish that p of 1 holds true. So let's see what p of n is going to equal. P of n is going to equal all of that. That's 1 times 2 plus 2 times 3 plus 3 times 4 plus ... n times n plus 1. And that's going to equal n times n plus 1 times n plus 2 divided by 3. So let's let n equal 1. Then p of 1 is going to be 1 times 2 on the left hand side, and on the right hand side it's going to be 1 times 1 plus 1 times 1 plus 2 divided by 3. 1 times 2 is 2, and here we have 1 plus 1 is 2, 1 plus 2 is 3. 1 times 2 times 3, that's going to be 6, and 6 over 3 is 2. We can see that the left hand equals the right hand side. And we know that p of 1 holds true. So let's start our induction and assume that p of n equals p of k, and p of k holds true for some k greater than and equal to 1. P of k is going to be all of this: 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus k times k plus 1, and that's going to equal k times k plus 1 times k plus 2 divided by 3. We're going to assume that this is true. So what is our goal going to be? We're going to establish that p of n is going to be equal to p of k plus 1, and p of k plus 1 is going to also hold true for some k greater than or equal to 1. So let's write out what p of k plus 1 would be. P of k plus 1 is going to equal 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus k times k plus 1 plus, this is when we add the k plus 1, that's k plus 1 times k plus 1 plus 1. We come here to the right side and we replace these k's here. Oops. We're going to replace those k's with k plus 1. And that's how we get this guy. So let's simplify this. And it's going to simplify to this: 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus k times k plus 1 plus k plus 1 times k plus 2, and that's going to equal k plus 1 times k plus 2 times k plus 3 divided by 3. So when we're looking at this, we can see here that all of this is this. And we're assuming this is true, so we can replace all of this with this guy right here. So here it is, and let's replace it. Now we have k times k plus 1 times k plus 2 over 3 plus k plus 1 times k plus 2. And that's all going to equal the right-hand side, which hasn't changed. It's still going to be k plus 1 times k plus 2 times k plus 3 over 3. So how can we make these two alike? Well, we can start by making the numerator of this guy here, not the numerator, I'm sorry, the denominator the same as this one, so we can add these two. Let's go ahead and do that. So we would multiply it by 3 over 3, which is just 1, so you haven't changed the problem. We can now bring these two fractions together. So here we have k times k plus 1 times k plus 2 plus 3 times k plus 1 times k plus 2 over 3. And that's going to equal k plus 1 times k plus 2 times k plus 3 over 3. You can see here that you can actually factor out this k plus 1 times k plus 2. Factor those out. And what do we get left with? We get left with, on the left-hand side, k plus 1 times k plus 2 times k plus 3 over 3 equals k plus 1 times k plus 2 times k plus 3 over 3. We can see that the left hand equals the right hand side. Therefore, P of k plus 1 holds true. So let's try it with another one, and let's prove using mathematical induction for any integer n greater than or equal to 1, n cubed minus n is divisible by 3. So let's establish P of 1 holds. Let's do our basis. So P of n is going to be n cubed minus n, and that's just going to equal 3 times some integer. We're going to name this integer n, but it's going to equal 3 times some integer, because we know that any integer multiplied by 3 will be divisible by 3. Let n equal 1. So P of 1 is going to be 1 cubed minus 1, which is going to equal 0. And 0 is divisible by 3. Therefore, P of 1 holds. So let's do our induction. Let's assume P of k holds for some k greater than or equal to 1. So P of k is going to be k cubed minus k. That's just going to equal 3 times an integer. This integer is going to be called n. So our goal is going to be to establish P of k plus 1 is also divisible by 3 for some k greater than or equal to 1. So let's factor this out, or multiply it out. K cubed, and k cubed is k plus 1 cubed, it's going to be k cubed plus 3k squared plus 3k plus 1. So we can replace this guy with all of this right here. We can also distribute the negative sign there. And that's going to leave us with k cubed plus 3k squared plus 3k plus 1 minus k minus 1. We can take out these 1's. We're now left with k cubed plus 3k squared plus 3k minus k. We can observe here that this k cubed and this minus k here, well, that just equals this, k cubed minus k. That equals 3n. We already know the answer to that. That's assumed to be true. So we can replace these two terms with 3n. Let's go ahead and do that. So now we have 3n plus 3k squared plus 3. Well, they all have a common factor of 3, so let's pull the 3 out. So now we have 3 times n plus k squared plus k. So let's just say everything in here, we're just going to call that r. And r is just some integer. So now we have 3r. So obviously, 3 times an integer will be divisible by 3. Therefore, p of k plus 1 holds true. Thank you.